Hey everyone, I'm Runnu Patidar and today I'm going to explain the third assignment of data science. So let's get right into it. So the first question of third assignment is supervised versus unsupervised learning. So the title is Learning Paradigms, Supervised versus Unsupervised. Supervised learning. Goal: predict a known outcome, target variable or label, data. Labeled training data, input, output. Algorithms: linear regression, logistic regression, decision trees. Use case: spam detection, price prediction. Now, unsupervised learning. Goal: discovered hidden patterns or structure in the data. Data: unlabeled training data, input only. Algorithms: k-mean clustering, PCA, dimensionality reduction. Use case: customer segmentation, anomaly detection. Now let's move to the next question. That is hypothesis, space, and find S algorithm. Title: Finding the best fit. Hypothesis, space, and fit S. Find S. Hypothesis space: the set of all possible functions. Hypothesis: the model can learn. The learning process is a search for the best hypothesis in this space. Find S algorithm: a simple non-backtracking algorithm finds the most specific hypothesis consistent with positive training examples. Final hypothesis: from assignment data, Japan economy. Consistent with all positive example, ignoring negative ones. That is find as algorithm. This is the second question. Now move to the third question. That is data splitting. Train, test, and validation. So the title is Robust Modeling Building, Datasets and Validations. Training set: used to fit the model's parameter, weights, and biases. Validation set: used to tune hyperparameters and perform model selection during development. Test set: used for a final, unbiased evaluation of the model's generalization ability. Cross validation (CV), a technique example k-fold CV that uses every data point for both training and validation across multiple iteration. Difference from simple split: CV provides a more robust and less biased estimate of performance than a single train validation split. So this is the third question. Now move to the next question. Evaluating classification. Confusion matrix metric. Title: Deep dive into classification matrix. Confusion matrix result n is equals to 20, and these are the parameters. Key metric calculated: accuracy, precision, recall, F1 score, type 1 error, specificity. And these are the following given metric calculated. Why precision recall matter more than accuracy in imbalance? Accuracy can be misleading, but precision recall focus on the performance of critical. High cost of Fn maximize recall. Now move to the next question, that is dimensionality reduction. Title: Reducing complexity, dimensionality reduction. Importance: mitigates the curse of dimensionality, reduces training time and computational cost, improves model performance and sometimes interpretability. Feature abstraction: transforming features, mechanism, create entirely new combined features, subspace, interpretability, lower, new feature lack original meaning. Example: principal component analysis. PCA. Feature selection: selecting subsets, mechanism, choosing a subset of original features. Interpretability: higher features retain their original meaning. Example: filter method, methods, correlation or wrapping methods. Now move to the next question. Model fitting issues, overfitting and underfitting. Title: Diagnosing model errors, overfitting and underfitting. Overfitting. Definition: model fits training data, include noise too closely, identification, low training error, high test error. Mitigation: regularization, early stopping, gather more data, drop out. Underfitting. Definition: model is too simple to capture the underlying data structure. Identification: high training error, high test error, both are poor. Mitigation: increase model complexity, more features or layers. Reduce regularization. Now move to the next question. That is linear versus logistic regression. Title: Comparing regression models. Linear regression. Purpose: predict a continuous numerical value, example salary, hypothesis, cost function, mean squared error, MSE, output range. Logistic regression, that is classification. Purpose: predict a categorical outcome, hypothesis, sigmoid function applied, cost function, cross entropy, log loss, output range, probability. Gradient descent optimization, an iterative algorithm used by both models to find the optimized parameters. It repeatedly updates parameter by stepping in the opposite direction of the cost function's gradient. Now move to the next question, that is data encoding and KNN. Title: Pre-processing and instance-based learning. One hot encoding. OHE. Purpose: converts categorical data like fruit into binary 0 1 column for use in ML models. And here is the example: fruit apple, fruit mango, fruit orange, fruit value of fruit, and all of them are converted into binary form. Next is K nearest neighbors, KNN. Mechanism: a distance-based non-parametric algorithm. Lazy learning: it stores all data during training and defers computation until prediction time. Prediction: based on the majority class classification or average value regression of the closest data points. KNN prediction: ID11 weight based on nearest neighbors, ID5, ID6, ID4 predicted weights. Now move to the next question, that is Python implementation. Conceptual. Title: Practical implementation in Python. Model training using scikit learning to implement linear regression evaluation, compute regression metric, RMSE, R square score, mean absolute error, MAE, and logistic regression evaluation, compute classification metric, confusion metric, accuracy, precision, recall, F1 score, specificity, log loss. Note: Python code structure involves data loading, splitting, training, prediction, evaluation. Now the conclusion is title, summary and next step. Key takeaways. Model choice depends on the data labeled or unlabeled and objective, continuous, categorical. Evaluation metrics like precision recall are crucial for model reliability, data preparation, OHE reduction, and addressing fitting issues over or unfitting are essential steps. If you have any questions, please comment below. Thank you for watching.